Kijk, daar zijn we. Hello everybody. My name is Paco van Beckhoven. I'm here to talk to you about keeping your head cool with a serverless voice-controlled fan. I'm a full-stack developer and I work for OpenValue. A bit of background. So how it all started. So the idea of keeping your head cool with a serverless voice-controlled fan came from a hackathon we had in France. I had set 3 goals for myself. I wanted to learn something about serverless. I wanted to play a bit with the Raspberry Pi and do something with the wire, a bit more than just converting your Raspberry Pi into a media center, which is already a long time ago. And I wanted to play with the Google Assistant. We recently received one, and it would be cool to make something for it myself, just to talk to it. But first, of course, I need to, before I explain how to do it, I need to explain why you should do it, because it's very important. So the problem, you wake up in the middle of the night and you're very warm, usually with your eyes closed, and then you want to turn your fan on, but the problem is the fan is out of reach, you cannot reach it, it kind of sucks. So there you have 2 options. You can either just get out of bed, but that means you have to open your eyes and move, or, and that's of course where it's all about, you can just shout to the fan, and then from there on, the fan will turn on, and you can just continue sleeping, keeping your eyes closed, and it's all nice and relaxed. So what we want to achieve is go from talking to the Google Assistant to getting a nice breeze. This also works during day. You don't have to wake up in the middle of the night to scream to the fan. So what do we need for this? We have, of course, we need to be able to convert speech into actions. So when I say something, it should be interpreted. Somebody should extract that whether I want to turn it on or off. I of course need a fan, and I need something to control the fan, which in my case will be a Raspberry Pi. And I need serverless, mostly because it's a buzzword, but also because it kind of glues the whole thing together, and it's nice to learn about serverless. So I'll just also start with serverless. The main idea behind serverless is that you want to be able to run code without managing or provisioning services. You don't want to worry about operating system updates or whether everything is working as you want. And serverless comes in 2 tastes. It's about, it originates, the first part is backend as a service. So you had, back in the days and when Android was kind of starting, the mobile backend as a service. That's where it originates from. For example, you had a mobile app and a website, and you wanted to be able to share state between these things. Like you have a database that was used by both apps, and you wanted something to run a database in the cloud without having to build a REST API around it and everything. And there were also authentication servers. So that's a bit of the idea of backend as a service. Then you also have functions as a service, and functions as a service is what is getting more and more popular currently. AWS Lambda is, I think, the first one that really made it big, and currently everybody has it, of course. And this is all about running small pieces of business logic. So it's purely computational. You just have a function, and it runs in the cloud, and it can be triggered by an HTTP endpoint, or depending on the bubble you're in, like the Google bubble, you can also integrate it with all the other services, or if you're in Amazon, you can couple it to API Gateway or anything else. So that's a short background on serverless. Usually what you also do is if you're building something serverless, FAS and BAS go hand in hand. You will probably need a database if you want to build something cool. So then the part where we start to control the fan. So we need a Google Assistant, which is comparable to Alexa and Siri by Amazon and Apple. We need to access a Google platform, which is there to, which allows you to extend the functionality of the Google Assistant. So you can define custom applications. For me, it will be the serverless fan. And we have Dialogflow. And Dialogflow is built on top of the Actions on Google SDK, and it is a website that kind of offers some more additional functionality and editors and click things, so you don't have to work with JSON files. So this will be the trigger of to turn the fan on, and it actually goes nicely in 3 parts. The Hey Google is what wakes up the assistant. The talk to serverless fan is that tells the Actions of Google platform that it should go to Dialogflow. And the final part, to switch fan on, is send to Dialogflow. So Dialogflow works with an agent. So you configure an agent. For each agent, you configure a set of intents. So in my case, I have an intent called switch fan, and this intent I define a set of training phrases like turn fan on or switch fan on, so that it knows how to identify the intent I'm saying. Because an intent is basically what a mapping between what a user says and what action should be taken. In addition to these training phases, you also define your parameters. So in my case, I have an on or off parameter, which is an entity you can define that only accepts on or off, because you don't want your fan to turn yellow, green, or 12. So to filter all these things out and to don't have the extraction yourself, you define parameters. You can also mark them as required, for example, so that if you forget to mention you want to turn it off, so you just say switch fan, then it will ask you, would you like to turn it on or off? This is all just clicking on a button and typing in a simple form. Then the next part, just to go back, so then the agent matches the intent, and then a response comes from the based on the fulfillment of the intent. And fulfillment is done per agent. So what you can do, you can either define a webhook, so just the IP address of your Raspberry Pi, and you can communicate directly to your Raspberry Pi. The disadvantage of this is that you will probably run into firewall issues if you're going from conference to conference or to different places and IP addresses and stuff. So this is kind of inconvenient. Plus, of course, I wanted to learn about serverless, so we use the nice inline editor that allows us to just immediately put in our Firebase function, which is the functions as a service that I mentioned earlier. And in basic, this is what you get. You have some simple imports, some requires, and a nice HTTP callback method. The request is what contains. The request is filled by Dialogflow, and it contains all the information on your invocation. So it also contains some context, whether it was exactly what the user said, or the turn parameter. So if we would fill this in, we have a function called switchFan that takes an agent parameter, and the agent allows you to talk back to the user, to the Google Assistant, which will then speak it for you. And there's an intent map, because as you have multiple intents per agent, you also will have you only have one function, so you want to switch different intents. For example, if I would build something like turn heater up, that would be a different intent and a different function, so you can switch between these. Now we're somewhere in the cloud printing or talking back and saying that we're switching the fan on, but we're not doing anything because we're still somewhere in the cloud and we need to go back to the Pi. So for this, I used the Firebase real-time database. It's a NoSQL streaming database that allows you to subscribe to certain paths or objects, and if changes occur to these objects, you can take action. So this is the server part, so here we only write to it, and because we're in the Firebase bubble, it's as easy as adding 3 lines, and now we write to a fan object with a state attribute, and we, based on the parameter, we turn it either on or off. So that's the server part. Now, of course, we also have a client. This is also a Node script running on the Pi. The Pi has a simple, I think it's called even the noobs distribution, which is just the basic version you have, and an index script that starts on startup. Here we also define our dependencies, this time only to Firebase, the database. And because we're no longer in the Firebase bubble, we also have to define some credentials and an URL, but that's it. And then we just define a callback function, so if anything changes in the fan object, we at least log that whether we're switching it on or off, but still, the fan is not going on or off. So for this, we need to, we use our Pi. The Raspberry Pi has this nice set of pins at the, as you can see it here as well. I can't point to it, but it doesn't work. But still, each of these pins have certain purposes. So some of the pins are just for outputting 5 volts. Some of them are grounds that you can use for the circuit. And most of them are GPIO ports, which stands for General Purpose Input Output. And these can be used to either write to output voltage, or you can read from sensors. So if you have a light sensor, it will either output, you can read from it whether it gives a high or a low signal. Unfortunately, this fan doesn't run on 3 volts or 5 volts. It runs on a 230. So we need a workaround for that. For this, we use a relay. It's an electrically operated switch, which works with a small magnet. Yeah, basically it breaks the circuit. So you take the cord of your fan, you cut it in half. You connect one of the 2 wires, the other wire you put a relay in between. And as soon as the relay is powered, there will go small voltage through the magnet. The magnet will close the circuit, and then that way you get it will go on. That's the basic idea of a relay. And then the last thing is to actually control this relay, and that's basically controlling the GPIO ports from the fan. There's a million libraries out there for each language that you run on the Pi. There's also at least 3 GPIO related libraries. I picked the one that has the least amount of lines needed. Usually there's exception handling and all kinds of stuff, which you do not necessarily need. You just have a pin. In my case, I hooked it up on pin 40, and then you set it up, because as I said before, you can either read or write. So have a sensor, or you can output 3 volts. And then you turn it on by putting a high signal. So just to give a small recap, we started all the way at the Google Assistant. From there on, we received a command that told the Access Google platform to go into the serverless fan application. There it went to Dialogflow, which matched it to the right intent. From there, we extracted the term parameter that went into the real-time database. We streamed on the Pi using the Firebase client. And then we used the GPIO ports to turn the fan on or off. So now, of course, the most important part is the demo. This is for backup, because I hope to make it work here. So for this, I will use, I have a Google Assistant here on my phone, which you'll have to believe, because it's kind of inconvenient to demo it. So, talk to serverless fan.
All right, getting the test version of serverless fan.
Greetings. Use turn fan on to start a breeze.
Turn fan on.
Keeping your head cool.
Turn fan off.
Stop keeping your head cool.
Yes. So, what you also noticed, I'm not sure whether you could hear it, but as soon as you go into your own application, you get a custom voice, which you can configure all the way. So what you normally do when you talk to the Google Assistant, you get a Google Assistant voice, but when you're in your application, you can do whatever you want with it, which also sometimes sounds a bit awkward, because then you think like, where am I talking to? But that's basically the idea. I put a GitHub repository with the slides and some useful links if you want to get started. There's links to tutorials that I also use to get us all to work. And if you liked it, please rate it. And thank you.